All right, so the FDA regulates that fish is consumed is allowed to contain 1 milligram of mercury. In Florida, bass fish were collected in 53 different lakes. So do the data provide enough evidence to show that fish in Florida has more mercury than the allowable amount? Okay, state type 1 and type 2 errors in this case, consequences of each error type for this situation from the perspective of the FDA and the appropriate alpha level to use. State why you picked this alpha level. All right, so they're not really asking us to perform the test. They're just asking us to say what a type 1 and type 2 error is. All right, so the null hypothesis is that mu equals 1. The alternative hypothesis is that mu is greater than 1. So remember, a type 1 error is when you reject the null by mistake. So, in other words, we reject the null and we think the alternative is true. So the data lands here, but the truth is that mu really is 1. So what would that mean? So if we ended up with a type 1 error, then we're going to think that the fish contain higher amounts of mercury than they really do. Well, if we're talking about the FDA, what would they do? If they committed a type 1 error, then they might shut down fishing in Florida. It would have a dramatic impact on the economy of Florida if we shut down all the fishing because we think that the mercury levels are higher than they actually are. So we may take action against fishing in Florida when we really don't need to. We might also put in new restrictions on mercury when we really don't need to because the fish are actually safe. So what about a type 2 error? Well, a type 2 error is when we do not reject the null when we really should have. So the alternative is actually true, that the fish are actually dangerous, but we think that the data lands up here telling us that the fish are actually safe. So we fail to reject the null. And that's a mistake. All right, so if we fail to reject the null, so we think that the fish are good, but the fish are really bad, well then, if we commit that type of error, what's going to happen? Well, people are going to die because they're going to get mercury poisoning from the fish. So we have to decide, is it better for us to, which type of error is essentially the least bad error? So, and that's up to debate. There's not really a right answer for that one. If you think that the economic impact of shutting down fisheries or imposing restrictions on industry to reduce lead level or mercury levels is, if we think that has a severe impact, and we don't want to do that, if we want to try to avoid that, then we're going to want to have a small alpha level. So we reduce our alpha level maybe to make it 0.01 if we want to avoid this. If we think a type 2 error is really, really bad because we're killing people because they get mercury poisoning, and we want to try to prevent that, so we want to avoid a type 2 error, then we have to be willing to set our alpha level to be slightly larger, because remember, there's a trade-off between the alpha level and the beta level. So if I make my alpha level smaller, then I increase the chance of a type 2 error. If I make my alpha level bigger, then I decrease the chance of a type 2 error. So the answer to this question is it depends, and you're going to have to argue which type of error is the one that you really want to avoid. Do you want to avoid a false positive, or do you want to avoid a false negative? And remember, you can't guarantee that you're going to avoid them, but you can minimize the chances based upon what you set this alpha. Small alpha makes type 1 error smaller. Larger alpha makes type 2 error smaller.